There's so much noise in the AI space right now. Professor Ethan Mollick captured it perfectly when he said the use of every naming scheme piled on top of each other, from acronyms to obscure vocabulary to version numbers to qualifiers like Max, make it hard to see how big a deal each release is. GPT 5.1, Codex Max, Gemini 3 Pro, Gemini DeepThink, now Antigravity, Claude Sonnet 4.5. AI fatigue is real. But here's the problem, it's easy to tune out, but the actual technology is making massive leaps forward. This week I had a go at building a fully functional Doom style game in under an hour, using Google's new Antigravity platform. This was a prototype, but it was a playable game, but more on that later. Before we dive into Antigravity, we need to talk about the elephant in the room, hallucinations once again. Now, a few weeks ago, you may remember I covered research from OpenAI showing that we've been benchmarking models all wrong. We've been incentivizing models to guess rather than admit uncertainty. Remember the strawberry problem, how many R's are in strawberry, how many E's are in everywhere inference. Now we have new data from artificial analysis with their AI Omniscience benchmark, and it's not pretty, but it's an attempt to address OpenAI's observations about models. Gemini 3 Pro leads the pack with a score of 13 points on a scale from -100 to 100, and it's substantially ahead of Claude 4.1 Opus, GPT 5.1 and Grok 4. While Gemini 3 Pro achieved the highest overall accuracy, it still showed an 88% hallucination rate. Let's break that down. What does it mean? Well, it means that when Gemini 3 gets something wrong, it's incredibly confident about being wrong. It's not saying I don't know, it's making up answers with the conviction of a PhD candidate defending their thesis. Even with Gemini 3 Pro, we're making progress, but hallucinations are still a problem. The Omniscience Index specifically penalizes wrong answers as much as it rewards correct ones, and models receive no points for admitting uncertainty. This is exactly what that OpenAI paper we covered called for. Stop rewarding guessing. And the benchmark covers 6,000 questions across 42 economically relevant topics in 6 domains: business, humanities, social sciences, health, law, software engineering, and science and maths. And out of all the models tested, only 4 achieved a positive score. That's 90% of models failing to be more right than wrong, when they can simply answer I don't know. Now, this isn't just about Gemini. Of course, the other models showed high hallucination rates as well. But what is interesting? So what does this mean for large enterprise and devs? Well, it might seem obvious, but you do need to use multiple models. No single model demonstrating consistently strong factual reliability across all of the domains. For mission critical applications, of course, so you can't just deploy one model and call it done. Of course, you need a multi-model strategy, proper guardrails, and most importantly, infrastructure that can handle this complexity. And of course, if you're concerned about security, you can also use G-Core's everywhere inference. It's very easy to deploy, and with proper compliance and lockdown security and the ability to switch between different models. Okay, so we've established that Gemini 3 still hallucinates. We haven't quite solved that problem yet. But let's focus on what it does exceptionally well. Gemini 3 Pro tops the LM Arena board, and it demonstrates PhD level reasoning with top scores on humanities last exam without the usage of any tool, and GPQA Diamond at 91.9%. Beyond text, Google redefines multimodal reasoning with 81% on MMMU Pro and 87.6% on video and MMU, and it scores a state-of-the-art 72.1% on Simple QA Verified. So for coding specifically, which is of course what most developers care about, it greatly outperforms 2.5 Pro on SWE Bench Verified at 76.2%, and that's a benchmark that of course uses coding agents. And what's fascinating is GitHub reported that Gemini 3 Pro demonstrated 35% higher accuracy in resolving software engineering challenges than Gemini 2.5 Pro in early testing. Benchmarks can only tell part of the story. What matters is, can you actually build with it? And this is where things get interesting. Now remember, Google acquired the Windsurf team for $2.4 billion in July 2025, bringing the CEO and the engineering talent into Google DeepMind. And within 4 months, this team has delivered Antigravity. Well, let that sink in for a little moment. Google have paid more than what some countries spend on their entire AI sectors to acquire a team that could build this in 4 months. And this isn't an experiment, it is a strategic play. So let's talk a little bit about what Antigravity actually is. Antigravity is an agentic coding platform that aims to evolve the IDE towards an agent-first future with browser control capabilities. Now, unlike Cursor or Windsurf, where AI sits in a sidebar and helps you code, Antigravity puts the AI in charge of a dedicated workspace where the AI can look at your code, understand what you're trying to build, and write the code itself, test it, and then catch the problems. It's about making sure that there is less human intervention needed. So here's how it works in practice. You've got a manager view with users that can control several autonomous agents concurrently across various workspaces, with Google describing this as a mission control for spawning, orchestrating and observing multiple agents across multiple workspaces in parallel. We've got some artifacts, so Antigravity can provide context on agentic work at a more natural task level abstraction. We've got that necessary and sufficient set of artifacts and verification results. So that's things like task lists and implementation plans and taking screenshots and browser recordings. Now, this is probably the part that I think is most interesting, and the part that I like the most is that you get a task list of exactly what the model is going to do, and it ticks it off as it goes along, so you can see exactly where it's been. It has, of course, multimodal support, so developers can choose to use a model by Anthropic. You can even use, of course, one of OpenAI's open weights models like GPT-OSS. So that last point is crucial. Google isn't trying to lock you into Gemini. They're building an infrastructure that works with the best models for each task, and that's a mature approach. So here's what really sets Antigravity apart. It's not just about the IDE. In fact, when I was testing Antigravity by building a retro G-Core Defender game, which we're going to talk about in detail a bit later, something interesting happened. The agent insisted I downloaded Chrome to test what I'd built. Now, he didn't suggest this, it insisted. And it wouldn't continue until I had Chrome installed. Now, at first this seemed annoying. Of course, I use Safari. I'm a big Safari user. But then I realized that this is, of course, the ecosystem play. So we're not just choosing Antigravity over Cursor or Windsurf just because of their coding capabilities of Gemini 3.5 Pro. You're choosing it because the browser integration means instant testing and validation. Google are bringing all of their suite of tools with them, and that includes Google Search, which is obviously grounded into these models as well. And I believe Google have also said that they are introducing Gemini 3 Pro into their search functionality. So the Gemini models are optimized for the entire Google Cloud stack. So it's not about whether it's a good editor or not, it's because it's the center of an entire development ecosystem. Integration matters, and it's understanding that when your AI coding tools work seamlessly, that productivity gains actually materialize. Alright then, so here's the part you've all been waiting for. I decided to vibe code a Doom style game where we do what we do best and we defend a G-Core data center from cyber threats. So this was the prompt I used. Can you vibe code me a Doom style game, but we have to protect the G-Core data centers from attack? G-Core colors are yellow and black, and this is our logo. So I actually attached the logo as an image, which is pretty cool to the coding model. Now we could refine that prompt, but I think it is a good starting place, okay, for a prototype. And Gemini's strength, by the way, is that it should have enhanced context, so it can better understand what you're asking without having to rely on a massive prompt and you having to over explain yourself. So we can see what happens. The agent earlier on created a project plan with clear milestones, and it asked me to confirm the approach and write the core game loop in JavaScript. And of course it creates the 3D render using Three.js, and it even tests it in Chrome as well, and this is why it made me install Chrome. And it records a walkthrough video showing it working. So here's a little bit of a play with it for you. So the game is actually playable. You might look at the physics and say they're a bit weird. We may need some improvements on the scoring system, and you know, could I have done this faster by hand? Well, maybe if I already knew Three.js and had a boilerplate ready, but I will let you into a bit of a secret that Three.js is not my strong point. And really that's the point. Antigravity let me operate at the idea level instead of the implementation level. So I described what I wanted and the agent figured out how to build it. Now, is it production level ready? Well, no. Would I deploy this for real users? Well, of course not. Of course not with the way that it is in terms of the graphics, but also not without extensive testing. But as a rapid prototyping tool, this is of course revolutionary. Let's be a little bit honest then about some of the limitations, because there are several. And one of the big limitations was the issues with sort of credit exhaustion and model overload. I have to admit, I did have a bit of an error message about overcapacity when I first went to use it, and it took a couple of tries to get it to work. And of course, as with all closed source models, there are legitimate security concerns. We've all heard the stories of non-coders building out amazing apps, then not realizing that their API keys are exposed. Running open source models with proper sandboxing and security audits is of course the only way to stay fully protected, and this is why Gcore's approach to AI infrastructure is always about security first deployment. You can't just let AI agents loose on production systems without some guardrails. So in short then, here's what I think is what's really happening. We're watching Google make the same play that others have made. It's all about the ecosystem. Google have of course both invested in Cursor's 2.3 billion Series D, and they launched competing Antigravity, so they're hedging their bets, but they're ensuring that Google's models remain central to developer workflows regardless of which platform is dominating. And that's a brilliant strategy. They're saying essentially, we don't care if you use Antigravity or Cursor as long as you're using Gemini. Now for developers, this is great news. Competition is what breeds innovation, and it's an amazing time to be in coding. We have so much choice with Cursor, Windsurf, Antigravity, Claude Code and GitHub Copilot all competing. And that means the tools will get better faster. For enterprises running on platforms like Gcore, it means you need infrastructure, of course, that can support this ecosystem. Flexible development, edge computing for low latency is of course part of this as well, and compliance for regulated industries. So the future of software development isn't about one tool or one model. I think it's about orchestration, a word that has been much used in AI circles on LinkedIn, and that's about having the right models, the right tools, and the right infrastructure all working together. Is Gemini 3 Pro the best model? Well, I think you know by now what my answer is going to be. It really depends on what you're building. Is Antigravity ready for production at an enterprise level? Well, of course, not quite, but it's not that Antigravity is not ready, it's that you need to think about the suite of tools that you're using. It is, of course, as I said, about orchestration. I don't think that we're in an AI bubble, but I do think we are in a phase where the hype often outpaces the reality, and that's what makes it hard to see what actually matters. So here's my take on what does actually matter. For developers, the tools are clearly getting exponentially better. Antigravity, Cursor, Claude Code, they're all pushing the boundaries of what's possible. You want to learn to use them, but you also don't want to forget coding fundamentals. For enterprises, remember that multi-model strategies are essential. The best model for coding isn't the best model for legal analysis. You need infrastructure that supports this complexity. Of course, for everyone, AI fatigue is real. But if you tune out completely, then you miss genuine advancements. And you also miss out on advancements that could be really beneficial for your specific use case. By the way, if you've made it this far, then you're probably the kind of person who doesn't tune out easily. And that's exactly the kind of audience that we're building at Gcore. So don't forget to give us a like and a sub. What do you think? Have you tried Antigravity? Are you going to stick with Cursor? Are you concerned about the hallucination rates, and what are you doing to mitigate this? Or do you think the productivity gains of these AI tools outweigh the risk? Drop me a comment, hit subscribe, and I'll see you next week, because of course there is not ever a slow week in AI. There is always something interesting happening to talk about.